Hello everyone, trying this for round 2 for lecture 4. So sorry if you watched the first video because there were some mistakes in the slideshow that I have since fixed to make it a little easier for you guys. Okay, so we are working on the doodle sheet. First box you are going to work on is box box E. Describe the growth of the bunny population when resources were unlimited. So there was no starvation and no predators. Remember, press pause and do the work. I'm not going to spend 5 minutes giving you the opportunity to type. Just go ahead and hit pause, and that way you have as much time as you need. So this is something called exponential growth. So what that means is there's nothing inhibiting them, right? So they can just keep having breeding and producing offspring generation after generation because they have plenty of food. They're in a nice, safe environment. This is really unrealistic. It's very rare that an environment allows for this sort of growth. Okay, but exponential growth is the growth rate of a population that increases faster as the population grows. This only occurs when resources are unlimited. Box F, describe the growth of the bunny population when resources were limited. Okay, so when the food is limited. Okay, take a second, write down what you think. So here's an example from nature. This is the breeding male fur seals in the thousands. Okay, over the years, we see the population increasing, but at a certain point, it layers off, right? It levels off. Okay, so what is the pattern in this graph? Here's another one, right? The sheep starts growing, exponential growth, and then all of a sudden, they start to level off and get a consistent rate. And we see it again here in this Parsium culture and a Delphinia culture. Okay, so this key term is carrying capacity, the maximum population size that an environment can support. Every environment has a carrying capacity. They can only support so many life or so large of a population within a species. So this is the stereotypical graph showing carrying capacity. Carrying capacity moderates the growth of populations by slowing, stopping, or increasing growth that is dependent upon limited resources or conditions. So what that means is that we lose amounts of our population, whether it be from starvation, accidents, pollution, old age, disease, or predation, right? The environment can only support so many lives. Okay, if the food source of a deer population can only support 1,000 deer, that is the carrying capacity for that population. As the population of deer increases, the food source decreases. As the population of deer increases, the food source decreases and competition occurs. The deer that are better adapted to obtain the food source will survive while others will die off. Box G, limited resources prevent populations from growing exponentially. So that's what the natural selection activity, the FET activity, taught us about populations. Limiting factors. Factors within the environment that limit the population size. So in the case of the bunny, the amount of food would have been the limiting factor. Okay, the limiting factor is the resource that is the least abundant that would set the cap. If they were in a drought, the water would likely be the limiting factor. So limiting factors have the availability of living and non-living resources. Other things such as predation, competition, and disease also come into play. Will the carrying capacity stay the same forever? Likely not, because things change, right? We just finished the finches, and the carrying capacity dropped significantly once the drought hit, and it caused a huge drop in the finch population. 2 lessons from the natural selection activity. Box H. There is a constant struggle to survive, and survival and reproduction are necessary for change, right? You can't just survive, you have to be able to reproduce. In your model, you also said that there were different beak sizes in the finch population. So that meant that there is variation, right? Is there variation unique to finches, or do we find it in all species? So variation is not just unique to finches. It exists everywhere. Look at these birds. Look at these humans. You see variation every day. Okay, you're exposed to it. It's normal that no two of the same thing, especially in the natural world, look exactly alike. Look at these flowers. Aren't they cute? We have the tomatoes. So, Box J, do you think variation is norm? Well, we just looked through about 10 slides and variation existed in all of those species. So I'm going to say yes, variation is normal. Okay, we're going to look at this. So this is the mortality rate of infants. What we're seeing is that when infants are closer to the average weight, they have an increased chance of survival, right? We have variation in fish sizes. We have variation in height of people. We have variation in beak depths. This should not be new. We just did this. Okay, so is there a constant pattern? Describe. What is the pattern that you're seeing? Put it in your own words in box J. Okay, so box K and L. Okay, so when there was tough food, which bunnies were dying? What type of teeth did they have? Which bunnies were living? What type of teeth did they have? Okay. The wolves present, so that means there were predators. In this environment, the warm environment, which bunnies were dying? The brown and the white. Why? In box L, which bunnies were living? Why? Okay, it's going to be the brown or white. You have to decide which one was living or which one were dying in this environment. Next, wolves present in the Arctic. Which bunnies were dying? Why? And which bunnies were living? Okay, fill those out. So here's another example of an advantageous and disadvantageous trait. Would it be advantageous for the albino trait to get passed on to offspring? Why or why not? Okay, think about seasons. Think about hunting season. Would this be an ideal color situation to be if you're an elk? Is it an elk? Is it a deer? I'm not going to lie, I don't know. I don't know the difference. Key term, advantageous trait, is a trait that helps an individual survive in a specific environment or given environment. So a trait that is advantageous in one environment might be disadvantageous in another. That brings us to our next key term, disadvantageous traits. So this is a trait that is unsuitable for the environment and may lead to death in the struggle to survive. So what will happen if an individual with an advantageous trait gets to reproduce? Well, they produce offspring that looks similar to them. If more individuals with advantageous traits survive and reproduce, what do you predict will happen to the number of individuals born with the advantageous trait in the population? What about the number of individuals with the disadvantageous trait? Okay, let's review so far. We observed the phenomenon that traits change over time and wondered how it happens. We turned to finches to seek evidence that may help us answer our question. And based on evidence, we developed a model to explain trait change over time. We will further investigate our ideas, revising our model. Okay, so box N. The next model that we will discuss is the one proposed by Charles Darwin. So he proposed a model to explain trait change over time. He thought that more individuals are born in a species than the environment can support. There's first a struggle to survive, and within every species there is naturally existing variation. Variations of some give them an advantage over others in the struggle to survive, while more of these individuals will survive and reproduce than those with less favorable traits. Many traits are passed from parents to offspring, and then more individuals with favorable traits reproduce, so the number of individuals with less favorable traits increase in each generation. The number with less favorable traits decreases. Eventually, the favorable traits becomes the most common form, but variations still exist. Okay, so all of that need to get written down in box, I think it's box O. Nope, that's not box O. N? That was box N. All right, guys. Okay, so based on this model, let's see how Darwin explained a specific phenomenon. So how did giraffes with long necks evolve from ancestors with shorter necks? Okay, so many early giraffes had short necks, but there were some giraffes who had longer necks. As the giraffe population increased, there wasn't enough food within reach for all the giraffes. So the giraffes with longer necks had an advantage over the giraffes with shorter necks because they could reach higher. Whew. Sorry, guys. The giraffes with longer necks survived and passed on their long neck genes to their offspring. The giraffes with shorter necks died and did not pass on their genes. Eventually, giraffes with long necks became the most common. Okay, so we already did box O. Okay, so we already did box O. Okay. Box M, final model. There is an environmental change. There is variation in the population. Some variations are better suited to the environment and will give an advantage to in the struggle to survive. Some variations give a disadvantage in the struggle to survive and lead to death. Survivals will reproduce and pass advantageous traits to offspring. The advantageous traits become more common in the population over time, but variation still exists. So I know we did a draft model. You can add this to the bottom. You can delete it and add it, whatever you want to do. Okay, but this information needs to get copied down into box M. Natural selection is the process whereby individuals that are suited to their environment survive and reproduce more successfully than those less suited. Key term, evolution, is the genetic change in a species over time over many generations. Adaptation is a change in the genetic makeup of a population that will allow a species to better survive and reproduce in a given environment. So, look at this. Is praying mantis blending like a leaf? I think that's a gecko blending in like a leaf. A monarch butterfly, which is poisonous to birds, blending in to look like a poisonous snake. This is a mohawk larva that set itself up to look like a parrot snake. Okay, here is your box O. We already covered that. If you need to do this still, you can come back and cover it on your own time. The link is in the PowerPoint. Okay, I have my own video there. Okay, doodle sheet part 2, speciation. We only have a couple slides left, guys. Okay, so species, a group of populations whose individuals can interbreed and produce viable offspring. Speciation, formation of a new species from a pre-existing population. So we have a pre-existing population that slowly the traits change over time until we have new species. So box A, the requirements for species. Speciation can happen when populations have become isolated, geographic or reproductive isolation. Isolated populations then evolve independently, and mutations. DNA molecules change, leading to slightly different traits. And finally, natural selection. Mutated traits are selected for or against time. Over many generations, the trait that work in the best environment will be passed on. So all of that needs to get written down into box A. Remember, you're welcome to press pause to fill in the box. Geographic isolation. Geographic isolation is the physical separation of populations that prevent mating. So here is an example of geographical isolation. The A. Harris and A. licurius were once one species of chipmunks. Squirrels. Each species of squirrel will adapt to its own environment and over time will become genetically different. So they once lived in the same area and over time they became separated by the Grand Canyon. Okay. Different predators might be present, different resources, so they're going to adapt differently to fit their new environment. Reproductive isolation is when obstacles to mating or to fertilization between the population groups in the same area. So there are 4 examples of reproductive isolation. They live in different habitats, right? So maybe one lives in a tree and one lives on the ground. Okay, different mating times. One mates in the spring, maybe one mates in the summer. Different mating calls. And maybe they're just anatomically incapable. Okay, so that is it. Congratulations, you've made it through this doodle sheet. Yay! Have a good day. Make sure you're studying for the test, and I will see you next